Okay, so there are people still coming in, but let's get started. Some people may have constraints at the end. So my name is Julio Tino. I'm the Dean of McCormick School of Engineering. I'm here representing the intersection between Kellogg and McCormick. We are delighted to host Paul Daugherty, who is the Chief Technical and Innovation Officer for Accenture. And when I say representing Kellogg McCormick is because we are co-teaching a program for Accenture. The topic that Paul will be talking about and subliminally advertising this book that is in there is probably the topic of the ages. So unless you have been hiding under a rock, for the last 4 or 5 years, Northwestern has had two people that in the topic of the future of work have been at completely opposite extremes. So interesting is the relationship between these two extremes that sometimes they have appeared together doing interviews. One is Joel Mokyr, who basically invented economic history and who believes that the world will adapt to all of these new changes. And at the other extreme is Bob Gordon, who wrote a book maybe 2 years ago about the rise and fall of American productivity, and Bob is on the pessimistic side. He probably believes that nothing that has altered productivity has been invented since about 1960, okay? So it's important for us to enrich our thinking space by bringing people who have thought deeply about this topic. And so I'm delighted to introduce to all of you Paul Daugherty. Paul.
Thank you. Well, thanks, and great introduction, Julio. Thank you, and it's great to be here at Northwestern. And you can the subliminal advertising is very effective. You don't even notice the book, do you? But I'll start with a little history, because I think especially in light of the introduction and the different perspectives that Julio mentioned, it's sometimes good to look back at history and see how history has sometimes repeats itself and brings the same issues back to bear. And one of my roles outside Accenture is I'm on the board of trustees at the Computer History Museum. So I get to see a lot of wonderful history, and that we've tracked over the years with what's happened in this revolution we're going through with computers and semiconductors and everything that's driven this revolution. So if you go back 49 years ago, 1969, and these are all anniversaries within the last couple of days. So 49 years ago, 2 days ago, in 1969, two days ago in 1969, the first piece of text was sent over the predecessor of the internet, which was the ARPANET, which was the Department of Defense funded internet. So 49 years ago, 2 days ago, was the very first use of the very first form of the internet. And 49 years can seem like a long time in some ways, but 49 years isn't that long. So think 49 years ago, without any way to communicate electronically, without email, without all the things, mobile phones, social media, all the things we take for granted. So that speaks to the pace of innovation, and I'll come back to that in a minute. A second historical fact, and this was 80 years ago today. Who knows what happened 80 years ago today? 1938. Orson Welles' The War of the World broadcast was 80 years ago today. For those of you who aren't familiar, Orson Welles did a radio broadcast called The War of the Worlds. It was a science fiction radio installment, caused widespread panic, and led to a long debate far after that about how media was transforming society and how technology was transforming society and the good elements and bad elements of what was happening. So that's an example of the societal impact that technology drives. And then This one goes back further, but I like it even more. So it was 157 years ago, in 1861, 157 years ago, we had the first connection of the, transcontinental telegraph was the name of it, the first telegraph system connecting the country, across the country, end to end. 157 years ago. 2 days later, the Pony Express shut down. 2 days after the telegraph was opened, the Pony Express went out of business, which was the prior way of kind of delivering messages and courier services and such, which speaks to the pace of disruption. So think about that. The pace of innovation, these societal impacts that technology is causing, things like social media and such we debate today, and pace of disruption to businesses. Those are things that aren't new, as you can see from the historical examples, and that's really what we're writing about in Human Plus Machine, and what all the work that I do at Accenture focuses on. And we started out to write Human Plus Machine 3 years ago, and it was Jim Wilson and myself. Jim's my co-author. And we were on a different college campus. We happened to be at MIT that day in Cambridge, Massachusetts, in some meetings. And we were talking about the fact 3 years ago that we believe that there was a lot of mischaracterization and misunderstanding about what was happening with artificial intelligence. And I'll explain what that is in a minute, but we really felt that that we needed to do something to try to set the record straight a little bit and correct some of the thinking that was happening on AI, because we see it as a really pivotal technology, and we saw an opportunity to create kind of a roadmap for executives in how to think about the application of artificial intelligence to their businesses, to their organizations, and to their industry. So that's why we wrote the book. That was 3 years ago when we started it. The book was released 6 months ago in the US, and it's now being released in other countries. I just got back from the book launch in Germany, going to China next week for the Chinese launch, then Japan and Korea, a number of other countries as the book gets released across the world. And we're fortunate to have had very good reception to the book. It's typically been at the top of the AI lists, artificial intelligence book lists. And so the message is resonating and getting a lot of good feedback from the executives and government organizations we talk to, and I'll summarize that as we go through. But I know you're all busy here. Some of you are checking your phones, some are eating lunch, and that's all okay. Do whatever you need to do. But since you're busy, if you forget the rest of my talk, or if you get distracted, I'll give you the real thing to take away. And that's the plus sign that you see on the slide here right now. So if you remember nothing else about what I say, just remember the plus sign, because it's the fundamental basis of the research we've done and the work we're doing, is that we believe that the future era we're moving into is about human plus machine. It's not about the human versus the machine, the human or the machine, or the rise of the machine. It's about the human plus the machine, and I'll explain why that is as we go through the discussion. And the other thing that you should take away, again, if you get distracted, just remember this as well. Remember the word reimagine, because reimagine, we think, is a fundamentally human skill. Computers don't do reimagining. Machine doesn't do reimagining. It's a uniquely human skill, and we're at a point where it's really important to rethink our organizations and rethink the way we do business, which is why we at Accenture are very excited about the possibilities of AI, because it's leading to a lot of advances in terms of how we can run business and run organizations. But you need to take a different approach. So remember that reimagining word as well. So those are the couple of key points I'd ask you to take away. And I'd also say that with that human plus machine message, and I'll say this at the start and I'll come back to it at the end, I would argue that we've been in an era for the last, since the invention of the semiconductor in 1950, roughly 70 years ago, which started this whole information revolution. We've been in a period that I'd define as not a great period for humanity's use of technology. We've been forced as people and as individuals to figure out how to use pretty awkward, immature technology to serve our purposes. And that's true even today. If I look at those of you using your phones right now, you're using your thumbs to type on a keyboard on a phone that was designed to slow down your cognitive pace of thought. And we think that's the state of the art. Using a supercomputer with your thumbs that was designed in a way to slow your pace of thinking. So that's the way that that technology's evolved. And I would argue, and I'll argue throughout the presentation and come back to this at the end, that we have the potential to really be entering an era of increased humanity and increased human potential. And that's why this is an especially important thing to get right as you think about it. So, enough of the introduction. A little bit about Accenture. I've been with Accenture a long time, so I think I'm well qualified to talk about it. I've been with Accenture for 32 years. Started with Accenture a long time ago, and it's given me the ability within Accenture, which is a technology services company. We're the world's largest and leading technology services company. It's given me a great kind of catbird seat to observe the changes in the industry and observe the evolution of the technology industry. And Accenture's grown to be the business we are today. 460,000 people around the world, 40 billion in revenue, serving a lot of the global 2,000 companies and public service organizations around the world. And our mission, and why it's relevant to this human plus machine discussion, is our mission is to bring innovation to help our clients transform their businesses, to improve their business and improve the way the world works and lives. So innovation to improve the way the world works and lives is what we think about every day at Accenture, and it's at the core of our company, and why things like human plus machine, AI, and such are so important. And my role at Accenture is Chief Technology and Innovation Officer, so I think I've got the best job at the company. I get to have a lot of fun. But it's all around setting the technology direction for Accenture and where we're heading, and working with our technology partners, working with our clients around the world, and also working with governments around the world. I spend a lot of time in Washington, D.C., and Beijing, and Brussels, and other spots around the world, talking about how these things are reshaping the way, governance and the way we need to approach technology as well. And we'll get into that a little bit as we go, and happy to take questions about those angles too. So that's Accenture. And now let's kind of get into this human plus machine thing. We're living, this is a slide just to illustrate the fact that we're fortunate to be living through, I would argue, a very important time in human history. We're at the start of an era where technology is reshaping the way our human experience, as I said earlier, in really fundamental ways, and technology is creating amazing potential to do new things. So you can see some of them on the slide here. You may have seen some of these videos before. How many of you have seen Sophia in the middle right-hand side before? A few of you have seen Sophia. So Sophia is an advanced humanoid robot who has a lot of interesting capabilities. Sophia can answer questions and such, but that's not the impressive thing about Sophia. The impressive thing that David Hanson, the creator, is doing with Sophia is creating the ability for a robot to form a human connection with a person, to form a real connection. So Sophia knows, if I stare at you too long, you'll get uncomfortable. You want me to look away, or you'll look away and blink. Sophia's learned this behavior of how to form emotional connections with people, and that's all been learned through machine learning. Thousands of hours of video she watched to understand how people communicate, how people form connections and such. And if you haven't seen Sophia live, she's a very impressive display of what can happen with humanoid technology. But there's other interesting things up here. Here's some work with Walmart. And this is, what's the biggest event of a retailer every year? Black Friday, right? But Black Friday only happens once a year, and there's no dress rehearsal really for Black Friday. But there is. We did this, Walmart did this with virtual and augmented reality so that they could use AI and simulations in a store manager's and store associate's own store to anticipate what would happen on Black Friday before it happened, and better be able to then respond and create the interventions and such you needed to really have the success that you needed to have on Black Friday. So interesting use of the technology there. Other interesting things, that you see the robotic surgery. You've probably seen a lot of examples of that, but remarkably accurate due to machine learning and artificial intelligence that's used. Some other interesting things here. We have blockchain and Bitcoin in the top right, which I'm happy to talk about a little bit more. There's some interesting connections there with AI. In the center, anybody recognize the center video?
as a quantum computing from D-Wave.
D-Wave, yeah. So you probably saw D-Wave, quantum computing. So D-Wave, Rigetti, Fujitsu, IBM, Microsoft, many are building quantum computers now. The one thing I say about quantum computing is it's the one I got wrong. I've got a lot of technology predictions and directions right over the years. Quantum, I thought, was going to come about more slowly than it is. Quantum is accelerating faster than we thought. I had taken it down a peg on our research agenda about 8 or 10 years ago, and I had to put it back on and elevate it because about 4 years ago it started moving faster due to some advances. And I'll come back to quantum computing because, again, it's very related to AI because quantum computing offers a way to do things, almost immeasurably faster than today's computers, given the nature of quantum mechanics, but let's say hundreds of millions of times faster than the fastest traditional computers, classic computers today. And it's an important thing to factor in. And quantum's largely today able to process AI-related mathematical algorithms very effectively. And in the top center is, the caption gives it away. It's CRISPR-Cas9. This is showing an example of editing genomics using the CRISPR tool, which can literally clip out DNA sequences from people, animals, and plants and such, and literally creating the ability to turn your genes into software and reprogram our individual code. And that has profound implications as well. So amazing things here. So how do you internalize that? I thought I'd throw in some humor since you guys are eating lunch. You can read it. I won't read the whole cartoon. But the problem a lot of business executives have when you go through a discussion like that is, what do you do with it all? And the guy's question here is, can you 3D print a blockchain and HTML it into a Bitcoin? It kind of sounds like it makes sense, but it's completely illogical. It makes no sense. And the question that we spend a lot of time with businesses on is, how do you make sense out of all this technology? And one underlying theme of everything I talked about in those 9 tiles was artificial intelligence. And that's kind of why we're here in the room, why we wrote Human Plus Machine. And AI, I would argue to you, is the trend that's going to shape the future more than any other trend. There's lots of trends that we track. I can go through any of the ones you want to talk about that you might be interested in. AI is what I call the alpha trend. It's the trend that's going to shape all the other trends. It's the trend that's allowing the other technologies on the prior slide to be possible, which is why we believe AI needs a special kind of attention and focus. But at the same time, it's very early days with AI. And I know many of you in the audience study AI in the AI program here. So you're aware that AI is an old profession. AI has existed since the Dartmouth conference in 1956, when McCarthy and the group of researchers at the time came up with the term artificial intelligence. But I would say, despite the fact it's 60 years old, it's still a very, it was still at the very early days of the application of AI. So we're early, and I'll explain why that is in a minute. And it's just another thing. This is what I liked. I saw on you guys, some of you might have seen this in your Twitter feed the other day. I kind of like this one. But this is, so in terms of where are we with AI really, we're not at this point with AI. Where AI is not at the matrix level of capability where it's running the simulation of the whole human race. So that's not what's happening with AI, and I'll come back to some of the myths in a minute. But what AI is it's really, all the excitement around AI is really coming out of the machine learning branch of AI. There's multiple branches of artificial intelligence. Machine learning is one branch of artificial intelligence, and for a while it was the forgotten child of artificial intelligence because people were more focused on expert systems and other research. Then what happened? Then what happened is we started inventing more powerful computing. We started having sensors and mobile phones and other things that collect a lot of data. And we had advances in some of the machine learning algorithms, things like backpropagation that you may be familiar with, and advances in backpropagation that allowed us to do more complex learning hierarchies and learning networks and neural networks. And that created this explosion of relevance of machine learning. And machine learning became the AI technique that jumped back into the limelight about 10 years ago when we hit this inflection point around computing, data, and algorithmic advances. And again, it's all around the learning paths. It was where most of the excitement of AI is today: supervised learning, unsupervised learning, and in these set of related technologies. So that's kind of what's happening now. But what the interesting thing was, machine learning, if you think about this from an IT, like an information technology perspective, the interesting thing about machine learning is it allows you to solve problems you couldn't solve before. Computer vision. We couldn't get using traditional programming where you had to program, write the code, test the code, sequentially figure out exactly the logic that you needed to use to recognize objects. Very, very hard. And very hard to get any decent level of quality. So computer vision research was stuck. Then using machine learning approaches, we were able to get very high quality vision. Same with speech, same with some other areas. And that led to all these applications of AI that we're talking about today. Intelligent agents, autonomous transportation, intelligent products, biometrics, analytics, some of the other things we've been talking that I showed on the slide that we've been talking about a little bit. And this is why the field of AI has gotten so exciting, is because of the branch of machine learning primarily applied to these areas. The one thing I'd tell you about, in terms of this, the where are we with AI question, is we're still early because there's other branches of AI, symbolic reasoning and knowledge graphs and many other things that are creating new types of ways to add intelligence into solutions, and that are going to continue to create new opportunity for innovators and business executives and others to do amazing new things with AI. So one of the comments I always make is there's no finish line in the foreseeable future with AI, because AI itself is advancing and changing rapidly, which is something that you really have to stay on top of. So that's AI, and part of why we wrote the book was to reframe the AI question from everybody knows what's on the left. What's the left? Go. When we started the book, especially, that's all people wanted to talk about is computers are beating all of us at games, and AlphaGo went from one game to another. And we wanted to shift the discussion to what's the amazing possibility of what you could do with AI. And on the right is an example I'd like to talk about. How many of you recognize what that is? Oh, you know, it's exactly AeroFarms, yeah. It's a vertical farm. It's called AeroFarm. It's run by a guy I know in Newark, New Jersey called David Rubenstein, who started the company. And it's an AI-powered vertical farming operation that, using AI, is able to do things you can't do anywhere else on the planet, at least in a natural environment. So no soil, no sunlight, 95% less water than traditional growing environments, 30,000 data points managed on every seedling from planting through harvest. And as a result, they can harvest in 18 days, 20 crop cycles a year, far, far more than you can do in any kind of natural growing habitat around the world. This picture is from Newark, New Jersey, creating food supply in a food desert, creating jobs in an inner city, eliminating a food supply chain, and able to do amazing things through AI, like what David will talk about if you visit his farm here. Is if you like your kale, let's say you like your kale a little bit more crisp and less bitter. Through AI, we've learned the light patterns and organic nutrient patterns that make the kale grow in that fashion. So you can have personalized produce in addition to all the enhanced growing productivity. Anyway, and that's really the potential of AI. One small example of how we can use AI and other technologies to transform business, transform the way we're used to doing things. And why I was very frustrated that we spent so much time talking about Go, which I would argue wasn't even all that surprising of a breakthrough. And we need to spend more time celebrating examples like AeroFarm that you see on the slide here. And that gets into the three key topics I'll talk about with the book. I'll talk about 3 myths, and then I'll talk about 3 big ideas in the book, and then I'll talk about 3 unsolved challenges. And this way you don't need to read the book. I hope you do all read the book. I'll explain why I hope you read the book, because there's an important reason why I want you to read the book. But I'll give you all the key messages of the book here so you have a summary. The first are the 3 myths that you see right up there. The first myth is that the robots are coming for us, and we strongly don't believe this is true anytime in the foreseeable future, defined as the next couple of human generations or more. And the Skynet Terminator scenario, or HAL 2001: A Space Odyssey, pick your science fiction dystopic future. That's really not the issue to worry about. We can talk more about that if you're interested. Happy to get into it in more detail. That's not really the short-term pressing issue. The second myth is that machines will take all the jobs. And our view, different than others, as as Julio suggested earlier. Our view is that that's not the case. And we believe that it's actually more likely that AI will create more jobs than it displaces. And when we started the book, this was a very provocative message, and I spent a lot of time debating and arguing with people about this. This has now come around to be more, I would argue, more of almost a mainstream view that people have come to accept. But I'll get into this more because it's an important thing to understand, because it'll create different jobs than the jobs that we have today, and that's the important thing to understand. And then the third approach is third myth is that the current approaches are still applicable. You can do the same thing you're doing in an organization, apply AI incrementally, and get the same and do okay. And we don't think that's true as well. So I'll explain that more in a minute. So those are three myths. Then there's three imperatives. And these are what we spend 8 chapters of the book writing about. I've done a lot of research on, and we have a lot of work at Accenture, further work going on in these 3 areas. And these are the 3 areas I would argue and encourage all of you to think about a lot as you look at learning about AI or applying AI, depending on where you are in your career. The first is, I'm going to go through each of these with a few slides to talk about them a little bit more, because these are the important things to understand. The first is this idea of reimagining business, and back to this imagination concept I talked about earlier. So by reimagine business, we mean we need to get out of the mindset we've been in for the last 150 years in designing organizations and designing business. A lot of organizations, a lot of our business processes reflect what you see on the left here. That's Henry Ford's factory. That's an early assembly factory of that era. And that was about automation, scientific management, inflexible processes, largely taking the physical work of people and automating it using machinery. And that kind of led itself into the early stages of IT automation. The very first corporate IT system was built in 1954 by which company? This is a gimme. Accenture. I thought you'd get that one right, especially the Accenture people here. Shocking. We'll have some new history lessons tomorrow. The very first business application of computing was the GE appliance division in Cincinnati, Ohio. They bought a UNIVAC 1, the very first UNIVAC coming off the assembly line, didn't know what to do with it. Hired us, our predecessor company, Arthur Andersen, which Accenture grew out of, to write the code on the UNIVAC 1 for a payroll application, the very first business commercial application written with a computer. So that was about automation. Then re-engineering came about in the late 1990s, 2000s. Re-engineering was about applying desktop technology and networks and databases, this first generation of information technology, to transform business. But the problem was, re-engineering led to big inflexible information systems. You typically invested hundreds of millions of dollars in information systems based on re-engineering exercises, and you developed static flowcharts of processes that locked people into very specific processes sandwiched in between different systems and computer processes and such that we developed. So re-engineering, while it drove a lot of productivity and drove a lot of improvement for business, really didn't unlock a lot of human capability, and really led to a lot of static, inflexible business processes and organizations. And I'd argue we're in this third era called reimagining, the word I've used before, which is about thinking of the problem a different way. It's not about a flowchart designing a process and a set of static information systems. It's about dynamic, adaptive, flexible, and personalized processes, systems, and organizations. And I'll get into this a little bit more, but it's about the notion that you can't design a standardized process and job description because the person's job itself is going to change continuously. We need to rethink the way we do these processes as a result. And if you think about this is kind of one way I've explained it to people. We're moving from assembly lines to automated human labor to assemblages of humans plus machines doing tasks together, and I'll explain more about what these assemblages look like in a minute. The interesting thing to take away, if you're a business executive or if you're thinking about advising a business, is based on the research we did for the book. And let me back up and tell you. So for the book, we did primary research, 1,500 companies around the world, many thousands more firsthand research with workers who are working around AI and other technology. So we had a robust research program which drove this research for the book. And the research of the book showed that about 9% of companies that we interviewed were applying AI in a way that was really reimagining or approaching the business differently. And those organizations were getting returns up to 6 times, as you can see on the page here, up to 6 times greater than competitors who were applying AI in a different way or weren't applying AI. So dramatically different results for companies that were taking this different approach to applying AI in their business and really taking this human plus machine approach in terms of creating this assemblage of human plus machine. Then the second big message of the book, the second imperative of the book, is this new approach to work. And we use the term a lot. I have started using the term collaborative intelligence rather than artificial intelligence. The problem with artificial intelligence is it scares the public because people think it's this artificial mind that's taken them over, which isn't true. And it's leads to a lot of the wrong discussions. So collaborative intelligence is what we're really doing here. We're using the best of AI and algorithmic and machine capability, combining with the best human qualities and creating collaborative, new collaborative approach to work, leveraging the best of the two. And this is really what, some of this was a surprise coming out of the research for the book. We didn't go into the book with this idea. This came out of the research for the book. And we identified 2 real categories of collaborative intelligence, of new types of work. There's one category on your left here, on your left, which is where humans are helping machines. People are needed to help machines and manage AI in different ways. And I'll come back and talk about this because this surprises people. Everybody thinks about AI putting people out of work. This is AI creating the need for people to do things to manage AI itself. Not programmers, not machine learning people, it's other types of skills. So I'll come back to this in a minute. The second category is where machines help people. AI helps people. We augment and improve the work people are doing and improve the capability of people. And there's 3 types of jobs you see there that I'll come back to in a minute as well. And I use the term that this is a case where AI gives people superpowers, gives people the ability to do things in new ways. And that's this other category of jobs. And the term that the media has picked up a lot from our book is we called this the missing middle. And you'll see this term in our book. And that's what has been really picked up by a lot of people. And the reason we call it the missing middle is we think this has been missing from most organizations' thinking. Most organizations are going in looking at how to apply AI to my back office and eliminate 500 roles, which is a machine replacing a human scenario. We think that's the wrong way to frame the problem. We also think this has been missing from the government and another dialogue that's been happening. The right dialogue is how do you combine the capabilities in the middle where people and machines come together? How do you combine the strengths that people have around emotional intelligence, collaboration, communication, extrapolation, creativity, other things like that? How do you combine those skills with what machines do well? Memorization, prediction, transaction, interpolation, versus extrapolation. And that's where the real missing middle is and the real opportunity is. So a number of people have come around to this point of view. Did you see this quote from Elon? Yeah, so Elon, they had the production problems in the Tesla factory, and I love this quote. He's, humans are underrated was his conclusion as they re-automated the Tesla factory and added more people in. And Elon wasn't alone. The opening chapter, first chapter of the book, talks about the Mercedes E-Class factory in Singlefin. Okay, so that's my German colleague in Germany. And in Mercedes, what they did is they recognized that the way they were producing E-Class sedans wasn't optimal. They had 80% of the effort was industrial robotics, 20% human. They changed it and went to 80% human, 20% collaborative robots that could be configured and controlled by humans, dramatically improved productivity in the output of the factory. And that's the kind of example we see very often as from our research. Now back to some of these missing middle jobs, what do these look like? So this is an example, AI personality trainer. How many of you have heard of this job? This is something we hire for at Accenture. Clients are hiring for as well. So it turns out how many you all know chatbots, virtual agents, those types of things. If you're deploying one of those for your organization, that's how your customers, your business partners, or whoever are engaging with your company. So we talk in the book of a chapter talking about the new face of marketing, and AI becomes your brand. AI is your brand. The way that chatbot or virtual agent's reacting to your customers is the brand of your company. So do you want to leave the way that chatbot responds to the engineers who programmed it or are training it through machine learning? And the answer from our experience in watching companies getting this right is no. You want to have an AI personality trainer, not just one time, because this is an ongoing job, but continuously evaluating the AI and training it to make sure the answers it gives are consistent, or first of all, right and correct, but beyond that, are they answered in a way that's consistent with the way you want to talk to your customers and treat your customers? If the customer asks you something off topic, they could ask you about a political candidate, they can ask you anything. Are you answering in a way that strengthens your brand and increases your credibility versus weakening your brand? It's a big issue. And the companies that ignored this in the first go around are really rethinking their position. There's some other things you need to think about here that are related job categories that we talk about. What is the brand you want to go to? If you're a consumer products company, do you want to use Amazon Alexa or Google Home as your front end to the consumer? Or do you want to develop your own? If you use Alexa as your front end to the consumer, does that create a disintermediation risk for you? Those are the kind of things you have to think through. And how do you avoid that? And that's where all these types of skills around how you interact and how your customers will interact with AI becomes important, and where AI really becomes your brand. Another interesting category are sustainers. And a great example of sustainers, but just the definition of a sustainer would be somebody who's responsible for managing AI on an ongoing basis. And you say, well, what does that involve? Well, there's a lot of different roles that are needed, like AI safety engineers that we talk about here. This is a real job post, a real job category and postings that you can find out there if you search. AI safety engineers who are looking at the overall safety implications as algorithms and AI comes into different processes. How do you assure the safety of the overall process? Again, not a machine learning expert, somebody who understands the overall context of the business that's happening. Another good example of this is what Facebook did following Cambridge Analytica. I'm sure all of you followed the Facebook Cambridge Analytica story and what happened. If you followed what Mark Zuckerberg did after he testified to the EU and he went to Washington, he then came out with an announcement saying we were wrong. Algorithms can't police other algorithms. We need people to oversee these algorithms and the key processes. And he announced they're hiring 30,000 people in these sustainer roles that are not technologists all the time, some of them will be, but people who are managing the algorithms on an ongoing basis. So those are some jobs on that left side where humans are helping machines. On the right side, there's lots of examples where AI gives people superpowers. One of the examples I like to talk about here is, it's not really you don't really see it on the right-hand side there, but a good illustration of this is where AI can help people with superpowers is, first of all, in those factories I talked about earlier, where people are using collaborative robots in different ways and developing the skills to configure the robots in the right way to enhance the productivity of the factories. That's a good example, and that's what we call embody, the embody class of jobs. Another example is in this amplify category, work we're doing and examples we see in financial services. One of the really interesting areas of AI we're working in now is called regulatory and compliance-driven AI. Doesn't sound all that exciting, but there's a tremendous opportunity to apply the pattern recognition and other capabilities of machine learning to dramatically improve regulatory processes. This kind of sounds straightforward once you really think through it. And an example where we're applying this in banks is in anti-money laundering processes, where you would have had thousands of people scanning transaction logs, trying to find instances that may represent fraud or connections between people that may represent money laundering activity. Well, it turns out equipping those people with a machine learning filter to better prioritize the transactions, to understand the real patterns in the data, to learn the correlations that lead to real criminal activity, gives the human investigators a great deal of power, gives them the superpower to then use their time more effectively tracking down and capture criminals, which is a human activity, the investigative part of it. And if you look at the banks doing this, they're moving from somewhere like 70% to 80% false positives in chasing the wrong leads to something like 20 or 30% false positives, people now focused on the right things. And that's one simple example. There's many, many others of this area where people are machines and AI are amplifying human characteristics. Then some interesting things, I'll just share this with you quickly. You can read more if you're interested in the details here, but this varies widely by job. and job type. And so we got into this in our research. We just released this week, this report just came out, I think, actually last week. I think it came out last Thursday. It's follow-up research to the book that we did. It shows an analysis by type of skill and type of job of how much of it's automatable versus augmentable. Automatable meaning you can generally replace a lot of it. Augmentable meaning it's you're going to largely keep the human capability and give them different tools, as I talked about earlier. And you see it highly varying as you go down. So physical and manual labor will continue to be automated at a very high rate. Then you move up the spectrum here, and you see areas like engineering that would have a very high rate of augmentation to do the job more effectively, less automation inherent in the job. So again, we can send you other reports on this if you're interested. This is from a report that just came out with some other research last week. Then you kind of roll that up and look at it by sector, and it's also interesting as well to look by industry, depending what industry you work in. And this just shows the degree of augmentation versus automation by industry. And you see some interesting patterns, like in health and education, we actually think more of that's about augmentation, augmenting student and learner capability as well as augmenting educator capability. On the health side, augmenting care professionals and providing increased care through AI, human care, enabled by better machines and algorithms. So we believe health and education highly augmented, in terms of the application of AI with a lot of human capability. And then down on the other side, manufacturing with more automation capability built around the augmentation. So again, same report. You can look at that for more detail if you're interested in how this breaks down by industry. We also have it by country in there. And then this gets into some other data from the same research that gets into the types of skills, because one of the questions people always ask me then is, okay, so I buy your premise, I buy this augmentation, I buy the fact that jobs are changing. How do we train people, or how do I train myself? How do I develop my own career? And these are the skills that we see, increasing in importance in the human plus machine age versus decreasing in importance. So you can see it's some of the things I already talked about on the top half of the graph: the creativity, reasoning, socio-emotional intelligence and such, versus the more automation capabilities at the bottom. And that leads then to these other types of jobs. I showed one earlier, AI safety engineer. These are real jobs that I'm coming across as we go around and look at what's happening. So an explainable machine learning engineer. How's that for a job? Somebody who can explain what's happening in the algorithms underneath. This is what Uber needed when their car tragically killed a pedestrian in Tempe, Arizona. It took them a while to figure out what really happened, what the root cause was, how do they give that feedback back to the engineering team to prevent that from happening. That's not an isolated job need, that's an at-scale job need across many companies, across, I would argue, all companies that are deploying AI. AI interaction designer. This is beyond the chatbot design to what's the whole experience that you create with a person around the AI and other technology. AI is changing our human experience. It's changing. AI is really, in technology generally, is changing the way we engage, with our devices. It's about 70% of you in the room check your phone before you get out of bed in the morning, based on surveys. 3% of you sleep with your phone at night in your hand because you don't want to miss a message. I'm not going to ask you to raise your hands, but that's a self-reported survey. So as you look at how technology is changing us, if you have children, or if you observe, children, nephews and nieces or something, it's changing the way children interact with technology. Look at the way my children interact with Alexa, and what's okay to say to Alexa, what's not okay. Can you treat Alexa rudely? Is that socially acceptable behavior? So designing these experiences and understanding the interactions are really, really important for consumer products and for the way we design these things for our workers. That's AI interaction designers. FinTech AI innovation strategist, kind of an understandable one. These are just a few of many new jobs that we're seeing. And if I would have done this talk 30 years ago, I might have said, we're going to see a need for search engine optimizers. We're going to see a need for website designers. And a lot of people would have thought we were crazy by saying the internet would create these new job categories, but it did. And these are the types of other effects we're seeing. And then the third area, and I'll wrap up on this area, and after just explaining it, is responsible AI. And this is something that we think is really critical, really important. And if an organization is doing AI and not thinking about responsible AI, I would argue they're going to get themselves into a serious and material problem. It's just a matter of time. And so responsible AI is something we believe needs to be a code within a company. It needs to be a C-suite responsibility that you need to have assigned formally to someone, and it's something you really need to think through. So I'll explain why. How many of you are familiar with Isaac Asimov's 3 laws of robotics? Yeah, a number of you are familiar with them. So, basically saying robots shouldn't harm people. Robots should always listen to people unless it violates rule number 1. And robots should always protect themselves unless it violates rule 1 or rule 2. Those are Isaac Asimov's 3 laws. But the problem is if you parse that from a business perspective, it means nothing and really isn't applicable. So we came up with 5 rules of responsible AI. And we've got a lot of work going on around this and a whole toolkit around this. And we've actually implementing this in our company. And these are the 5 principles. So accountability means AI isn't accountable to itself, just like Mark Zuckerberg said. If you don't understand the human in your organization that's responsible for what AI is doing, you're going to have a problem. And that may sound obvious, but a number of organizations have implemented AI in a way where the only person who can take accountability is the CEO or the board. That's not where you want to be. You want to have somebody in your business understanding the context and application of AI and accountable, full stop for it. Transparency, I'll highlight transparency with another cartoon so you can read this one. Can you see it? So transparency means you shouldn't use black box algorithms for things they shouldn't do. So Santa Claus shouldn't use a black box algorithm to decide who gets toys. Was that what the point of that one was? But there's criminal jurisdiction in the U.S. that use black box AI for criminal sentencing guidelines. There's companies in the U.S. who have applied AI to employee evaluation and termination determinations. Those are things you should be able to explain to people, I would argue. So we're saying with transparency as a principle in your organization, it should be an explicit decision when you use black box AI that cannot be explained. And there's certain things in your organization you should not approach and not handle in that way. If you leave it to your engineers to decide that problem, as well trained as the engineers are, and even if the engineers took the ethics course that are being added to curriculums, that's not going to be enough to make these decisions in the right way for your company. So transparency is important. The good news is that this field of AI is moving very rapidly. Explainable AI is an area we're doing a lot of research in, as are many others. Generative adversarial networks and other techniques are, and LIME, local interpretable model execution. There's a number of techniques that we're able to use AI itself to explain other AI algorithms. And I would predict that over the next few years, this issue of explainability won't be as tricky of an issue as it is for organizations. But in the meantime, you just have to be very explicit and very careful in how you decide to apply AI and where. Honesty is obvious, but a number of companies, we have CEOs and senior executives of companies who have been indicted for criminal conduct for using AI and algorithms to break laws, but you shouldn't do that. Fairness is probably one of the biggest issues I'm concerned about for the future, which is how do we design AI algorithms that are fair and not biased? And there's a ton of examples I can give you. You've probably read many of them. Famous one in the news was a couple of weeks ago, Amazon suspended the use of machine learning in their recruiting algorithm because it was extremely gender biased. Because turns out their data set was trained on predominantly hiring male engineers. So the AI learned to screen out things like Society of Women Engineers because it wasn't correlated with success at Amazon based on their historical hiring behavior. That's an example of fairness being negatively impacted in the organization. We've developed something called the AI Fairness Toolkit, which is a way to test your data and test your algorithms to make sure they're having fair outcomes. And if you're developing AI and rolling it out at any scale, we believe you need to be really checking the AI for the right outcomes. And human-centric is what I've talked about through the whole talk. Yeah, you can read this. This is getting at some of those principles. So the impact of data and data transparency. There we go. Anyway. So that's responsible AI. And then 3 challenges that I'll wrap up on the last area really here from the book. The first is skills and learning. These are the grand challenges for all of us that are going to continue to work in this area for the near future, and I think the grand challenges for society. The first is skills and learning. So while I'm optimistic that AI will create a lot of jobs we're not thinking about today, and I am cautiously optimistic about that, I'm pessimistic that we're doing the right things in business and in society to prepare people for the new jobs. And this issue of learning and new approaches to skill development in business is critical. So at Accenture, we're investing $1 billion a year in continuous learning platforms and continuously training people, which we believe is part of the solution. Not enough companies are doing the same. There's more and more companies doing this. But from our survey, 65%, from the book research, 65% of executives believe their workforce isn't ready for AI, 65%. Only 3% are investing in additional learning for those employees. 2/3 see the problem, 3% investing. So we have a gap. Part of the issue is they don't know what to train the people in. Part of the issue is they think it's the government's problem. Lots of different issues, and we need public and private sector collaboration on this, which is what we're really working hard toward. Data is a big unsolved challenge. The biggest obstacle we face with clients when we go into do AI work with them is finding the data to move beyond a proof of concept stage to scale the AI. So that'll continue to be a big challenge, as well as the bias issue and understanding the context of your data so you use your data appropriately. And then the third challenge is this continuously learning about the new AI techniques, which is a challenge for organizations who are just struggling to understand data science and then statistical mathematical models, then machine learning, and then how do you keep up with a continually evolving landscape? And that's a challenge, and there's some solutions to that, but something that we have to keep working on. I'll skip past that, and then really wrap up. So we call this is the last slide, so we call this an Accenture, we call it applied intelligence because we believe it's about applying automation, analytics, and AI to solving problems for clients. It's about applying the great AI technology coming from open source and a lot of different companies to solving real business problems. That's the way we've characterized that business. We've got about 19,000 people working in that business right now. And the one thing I'd tell you, I've been at Accenture 32 years, as I said, so I started and led our cloud business for a long time and been involved in all these other technology waves that we've seen. No business has grown faster than AI from what we've seen at Accenture, measured in people we're hiring or client projects we're doing or revenue. And so we have 19,000 people working in these areas right now, growing extremely rapidly. It's a supply-constrained part of our business right now, and we expect that to continue as we move beyond this early cycle of adoption into clients adopting it at scale. And I think that was the last slide. So thank you. That's Human Plus Machine. I'd ask you to read the book for one reason. I said I'd come back to this. The reason I'd ask you to read the book is, as I said earlier, we believe this reskilling issue is the biggest issue we face as a society. And we have a lot of issues because of people who already feel left out or disenchanted or feel the wealth gap or education gap that we have in society. And the reskilling is important to make sure we have a more inclusive approach going forward. So we're donating all the proceeds of the book, not to me or not to Accenture. It's all going to nonprofits that are focused on mid-career reskilling in particular, because we think the mid-career population of people who are in the workforce, they might have a mortgage, they might have kids, whatever, that set of people is going to face the biggest challenges and is getting the least support and least innovative new help. So we're committing all the profits of the book to supporting those types of organizations around the world. So please buy the book because it'll support a good cause. Thank you. And that's what the real book looks like.
Okay, I do not know if I need this. So let me quarterback the questions so you can concentrate on the answers. So questions. There.
How do you think of the balance of the implementation of, How do you think of the balance of AI implementation throughout the world with happiness and measuring happiness metrics, particularly with the fact of all these people that need to be retrained who it's happening way too slowly and it's ripping apart their families?
Yeah, I think that gets back to this experience point. I think what's really important to understand is how we're applying the technology and how people are using it in the tasks they're doing. So, not sure about the correlation to happiness itself, but I think we increasingly need to think about the overall context in which somebody's using the technology, and is it making life easier or harder for them? And I think too many technologies and too many products are designed in a process of throwing the technology out to the market rather than thinking about how do we make the life of the consumer easier. And that's why I think some of the new technologies, like as we get more into gesture-based interfaces, other ways of interacting with technology, more accessibility built in for people who have trouble understanding information in different ways, is going to really increase the satisfaction and increase the experience that people have using the technology. and the technology kind of goes away. I think in 10 years, the smartphone is only 10 and a half years old. The iPhone is only 10 and a half years old. I think in 10 years from now, I doubt most of us will be using smartphones. I think we'll be interacting with technology in a very different way. And it's the happiness, I'm not sure where the happiness will go specifically, but the experience will be much more different and much more human and lead to more satisfaction in the way we do things. So that's, generally speaking, the way I think that'll play out.
Okay, any other question there?
Could you talk a little bit about the role you see in open source and how it would play in
Open source?
Yeah, so open source, you got that. And I guess a place to start would be, do you think that IBM's purchase of Red Hat is a one-off thing or indicative of a fundamental shift in the way technology companies operate?
Because of open source, you mean specifically?
Because of open source, specifically.
So I think a lot of the AI models, when you look underneath the big platforms that are deploying AI, are open source. If you look underneath, Amazon, a lot of Amazon services and such, you'll find a lot of open source. So I think open source will continue to be a driver. TensorFlow is a good example too, coming out of Google, right? A lot of examples like this. A lot of the best voice frameworks are open source. So I think we'll continue to have a lot of open source based innovation. I think that's a good thing because it creates more collaboration and speed of innovation across the industry. So I hope that continues. At the same time, then the way that that's all packaged tends to be proprietary. So every platform that has the open source baked in will want to lock you into their APIs and their services. And so I think we'll continue to see a lot of open source innovation, but we'll still see business models where they're heavily geared toward locking you into their specific way of doing things, similar to what we've seen in cloud. Is the IBM acquisition of Red Hat indicative? I don't know that it is. I think that was more of the dynamics of IBM seeing an opportunity for what Red Hat had to offer, and it happened to be open source, and open source is consistent with what IBM wanted to do in the cloud. So I think that's more isolated, although it has created a lot of investor interest now in the other open source companies. I don't know that it'll create a real consolidation event, though.
Another question there.
Hi. In terms of Accenture and research that you do at Accenture, do you think it's better if you focus on the general AI approach, or do you want to focus on one particular problem, solve it, and go on to the next one? And what do you think? Personally, what do you think is the best approach in solving AI, or even going towards a solution over there? Like you said that there's no finish line. That's fine, but. In terms of general intelligence or solving one problem at a time, what is the best approach?
Just to clarify, so an do you mean artificial general intelligence or general AI?
Artificial general intelligence.
Okay, artificial general intelligence we're doing some research on, but I believe that we're quite a ways away from real artificial general intelligence. There was just the annual AGI meeting about a month or so ago, and that was the conclusion of a lot of the experts there. I think we're further away from a real artificial general intelligence that's able to extrapolate across domains and really learn across the narrow domains in the way we train machine learning. We're quite a ways away from. So we're doing some research around that because there's some of the techniques of artificial general intelligence that are applicable to other problems, but we're not doing a lot of research on an outcome, assuming that there's a breakthrough in artificial general intelligence anytime in the next probably 10 years. It's kind of beyond that in our estimation, and just tracking what the other researchers around the world are doing. So we're directing our research into the machine learning areas that drive a lot of advanced. So I mentioned compliance-driven AI in supply chain, and AI in customer experience through chatbots and virtual agents are some of the areas that we're really prioritizing. There's others, but we see a lot of applicability in those areas. And we're doing a lot now around knowledge graph, semantic technologies, and symbolic reasoning, which are some of the other techniques that we think are poised to be able to combine with machine learning and enable us to solve new classes of problems that we couldn't solve before. That's the way we're approaching it.
Question there.
Yes, hello. What do you think about self-learning technologies? Because most of them are deep learning, neural networks based on the learning process. And what do you think about the future of self-learning AI technologies?
Well, I think a lot of the potential, a lot of the excitement around AI is its learning capability, but iterate and learn, train the neural network and learn from the experience over time. So I think that is really one of the fundamental payoffs from AI, is the ability to develop algorithms that improve over time in pathology for tumor analysis or whatever the field is that the AI is applied to. So that'll continue. I think the idea of having AI that can learn new domains, like there was the example, I think it was Facebook, who had they had AI that taught itself a new language, things like where it really learned in domains that were foreign to it. I think that's back in the artificial general intelligence category, and those breakthroughs are a little further away. But the learning, embedding this learning capability is very powerful. So in healthcare solutions, in areas like pathology and radiology and these types of areas where you can continuously improve based on more data that you process, that's really one of the great values that we get out of machine learning algorithms today.
Okay, one more question here, then you, and then we're done.
You talked about accountability and transparency. I think you mentioned the word ethics. Do you expect that any regulation is going to arise if it comes to artificial intelligence?
Oh,
yeah. I think yes, I think is the answer. So ethics is an important issue. Ethics isn't the only element of regulation. There's basic issues around data privacy and things like that we're already grappling with that are very much tied in with what we're doing with AI. Ethics will be something that I think we have to make some societal decisions on. There's a famous project that MIT launched. Can't remember the name of it right now, but there's the trolley problem of AI, where if a trolley's about to run over. If a trolley's driving a car and has a choice to kill the driver or a pedestrian on the street, which do you do? And what the MIT's research, I think it's called the moral dilemma or something like that, what their research showed was, as a society, we don't agree on the answer to the question. So somebody's got to make a decision on the right way to do it rather than just leaving it to the algorithms and whoever coded the algorithms to leave it to chance in that way. So I think there does need to be more guidance. I hesitate to say regulation because some of these things can't be regulated right now. So we're working with some governments on different types of regulatory approaches. Regulatory guidance, regulatory sandboxes to test out regulation is something we're doing in the UK. The USDA, the USDA in the US, the Food and Drug Administration in the US, the FDA, actually did a very interesting thing where they introduced a set of AI principles for the industry, which were very good for industry because it gave industry guidelines on where can we use AI, where shouldn't we, where might we be challenged, where wouldn't we be challenged. That's unleashing innovation because they didn't give regulations, but they gave guidelines. So I think in this stage we're in, we need more of that kind of cooperation. When I meet with the regulators in the US or other places, they generally are in that same space where privacy is something everybody wants to regulate more and believes we need some steps on the privacy. But when it gets to ethics and things like that, we need to learn a little bit more before we too heavily regulate some of the behavior.
Was your question asked? Okay, so you will have the last question. There.
It's always pressure having the last question.
It has to be good.
Hello. Yeah, so I wanted to ask, how do you think the responsibilities of the role of a explainable AI engineer, you said, right? Explainable machine learning engineer. That would be different from the traditional QA engineer, quality assurance roles that we have right now.
Yeah, it might be related. So the question, how does an explainability engineer differ from a QA engineer? It might be that that's one of the things that QA engineers do because QA is one of those processes that's getting heavily automated by AI. So that's probably a great thing to train a QA expert to do is they understand testing, they understand how you test and validate and verify system behavior. So how do you take it to another level and understand the outcomes, and explain the outcomes. So I think it is different, but I think that's a good example of where you might have an adjacent set of skills and you move a person along with a human plus machine approach.
Okay, so please join me in thanking Paul for a great talk.
Thank you. Thank you very much.